Hello fellow problem solvers. So today we're going to be doing a problem from the 2012 Romanian JBMO TST Day 2 problem number 1. This is a nice, simple algebra problem that I invite you to try for a minimum of 15 minutes, ideally 45 minutes but not more than an hour. If on the other hand you'd like to go along with us, I suggest you take 10 minutes and try to solve the problem. So now let's begin. So this is a problem setup. We have n real numbers, the first and the last one being equal to some constant a, and this condition holding. And we need to prove that every number is less than or equal to a. So one way to play around with it is say, okay, we know a1, an are less than or equal to a. What happens if the contrary is true for, say, a2? What if a2 is greater than a? Well, then we must use this condition somehow, and let's see what happens. Well, what happens is we have for k equals 1, a2 is less than or equal to a1 plus a3 over 2. Okay, this is greater than a. This here is equal to a. So that means that a3 will be then greater than, well, it seems like it will be greater than a as well. So then we have a3. Now we have a2 and a3 are greater than a. And we have a2 times a3 is less than or equal to a2 plus a4. And now here I invite you to take 5 minutes and see what would you do? How would you push this forward? Now the trouble is we can't really do anything straight away because we have just both of these are greater than a. Now this could be 50 times greater than this thing for all we know, just by knowing that both of them are greater than a. So now let's look back at the first thing we had. a1 was equal to a. We have 2a2 is less than or equal to a plus a3, and this is greater than a2 plus a. So we have not only that a3 is greater than a, but it's greater than a2. And now from here, an a2 is greater than a1. And now from here we can get that a4 must be greater than a3. And how do we do that? Well, we know this is greater than a2 plus a3 because a3 is greater than a2 and a3 is equal to a3. So we get that a4 is greater than a3. And then we'll keep getting that a5 is greater than a4 and so on and so forth till we get to the last number, an. We'll get that an is greater than an minus 1, greater than la 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 la, all the way till a2 greater than a, which is a1, but this is also a, and we have a contradiction. So now with this in mind, I invite you to take another 5 to 15 minutes and see how would you like generalize this sort of idea for a2. How would you solve the problem? Take 5 to 15 minutes now. So the next natural question is, if you can't generalize straight away, then just look, okay, what if a2 is less than or equal to a, which is equal to a1? Then just looking at 2a2 less than or equal to a1 plus a3, a2 could be so small that this will always be true. So let's look at the next one, 2a3 less than or equal to a2 plus a4. What can we get from here? Well, the issue is we can't really get anything. I mean, here we have a1 is greater than or equal to a2. Well, we can't get something along the lines of a3 is less than or equal to a2. Because for all we know, a3 could be greater than a2. Like it could be equal to a1 again, perhaps. We don't know. But the assumption that we are going under here is, let's say a3 is greater than a. Let's see, it's like the smallest one that's greater than a. So now what do we have? Well, we have a2, a3. Okay, this is less than a. Okay, so we know this thing right here is less than or equal to a plus a4. And we know this thing right here, what's it gonna be? Well, it's gonna be greater than, strictly greater than, a3 plus a. Now you cancel these two out, and you have a3 is less than a4. This is greater than a. And now the question is, can we continue doing this? And the answer is, yes, we can. We get that 2a4 less than or equal to a3 plus a5. This is less than a4 plus a5. And now you get a5 greater than a4. So we will be able to do this all until an, which is equal to a, and get another contradiction. Now, before I allow you to just go ahead and try to solve this problem, I want to maybe spend a little bit of time saying why did I immediately look for a contradiction. And the reason for that is I need to prove something holds for every I. And it's like, what do I get from it not holding for one I? Maybe I can use that for something else. Like, it's a complex thing for me to try to prove it for every I. Sometimes it's possible to prove this thing directly. However, for me, I couldn't see it, so I went with a contradiction. And it's a good way to think about what happens when the problem statement isn't true. Like, what are the sort of constraints that you're given once you assume that the problem statement isn't true, say for A2. Or it's not true for A3. Like, it gives you more constraints, so that is why I look at the contrary. And now with this in mind, I invite you to take another 10 to 20 minutes and try to finish the problem. Here's the solution. So what we do is we say that all the numbers A1 through AT are less than or equal to A, and AT plus 1 is greater than A. Assume such a number exists, and take the smallest number, which is greater than A. Let that be T plus 1, and now you have this. So here we can just use the fact that A2t plus 1 is less than or equal to AT plus AT plus 2, and because this thing right here is greater than A plus AT plus 1, and this is less than or equal to A plus AT plus 2, we get that AT plus 2 is greater than AT plus 1, and then via induction we will get that this is less than AT plus 3, and all the way till AN, but this is greater than A, this is equal to A, and we get a contradiction. And that's one way of proving this and writing it down. Now, a way that I would write the solution down is the following. I would say let the maximum among these numbers be AI for some I, and if I is equal to 1 or n, then we're done. Then A is the maximum number, then A is greater than or equal to AI for every I. Now, assuming this is not the case, we have this. And now this thing implies that because this is less than or equal to AI plus AI, given AI is the maximum, that means the equality must hold because these two things are equal. So it means that AI is AI plus 1 is equal to AI minus 1. And now you can see, let's take such that I is the smallest one. So we write that down saying, we say let the maximum among these numbers be AI such that I is the smallest possible. We know I isn't equal to n, the same mistake I made. So if I is 1, then we have A is equal to A1 is greater than or equal to AJ for every j among these numbers. Else, we have this thing right here, 2 times AI is less than or equal to AI minus 1 plus AI plus 1. And this is less than or equal to AI plus AI because this is the maximum among these. Now, because we have equality, this implies that AI minus 1 is AI plus 1, which implies that I minus 1 is actually the smallest one, which is a contradiction because we took I to be the smallest possible. In either case, this solves the problem and we are done. And as always, thanks for problem solving.